The function given by a of t equals 0.0275 t cubed minus 0.465 t squared plus 1.867 t plus 8.41 for t from 0 to 10 can be used to estimate the amount in billions of dollars invested by large oil companies in exploration for new reserves t years after 1995. Find the relative extreme points and sketch a graph of the function. Okay, so anytime we have a problem dealing with relative extremes, or sometimes called minimums and maximums, we should be thinking about derivatives. Okay, so the first thing that we want to do is take this equation and find the derivative. So we want to find a prime and this is a polynomial, so we will be exclusively using the power rule. So the very first thing is we want to take the t cubed, multiply the 3 out front times 0.0275. If we do that, we get 0.0825. And then the exponent decreases from a 3 to a 2. Okay, next we're going to use the power rule on this t squared term. So I'll be multiplying the 2 from the exponent out in front times minus 0.465. So if we do that, we still have a minus, and 0.465 times 2 gives me 0.93. And the exponent decreases from a 2 to a 1. Next term, 1.867t. The derivative of t is just 1, so that leaves me with plus 1.867. And then lastly, the derivative of 8.41, that's a constant, so its derivative is 0. So there's my derivative for a. And what we want to do is find the critical numbers for this function. We do that by setting this derivative equal to 0. To solve this for t, I notice that I have a squared as the highest power, so this is a quadratic. It's a fairly complicated quadratic, and so using the quadratic formula should be the go-to method for solving this equation. So the quadratic formula would tell me that t equals the opposite of the b term. b is negative 0.93, so 0.93 plus or minus the square root of b squared, so this is minus 0.93 squared minus 4 times a, 0.0825, times c, 1.867. Okay, and all of that is over 2a. All right. So to avoid too much rounding, we can go ahead and put this all into our calculator at once. So first we'll do this for the plus over here, and then second we'll do it for the minus. Okay, so the two answers I get from this. First we'll do 0.93 plus the square root over 2 times 0.0825, and then we'll do 0.93 minus the square root divided by 2 times 0.0825. So going to the calculator, I get for the 0.93 plus 8.6593 and when I do the 0.93 minus, I get 2.6134. Okay, so those are my possible places where I could have maximums or minimums. I still need to go ahead and test to see whether or not they are maximums or minimums. So I'm going to set up my number line test where I have 2.6134 and I have 8.6593. And so what I need to do is pick t values in these three regions. So a t smaller than 2.6134, a t between these two, and a t bigger than 8.6593. And I take those test values and input them into A prime to see if I get a positive or a negative. So I always pick 0 if I am able to. So over here I'll pick t equals 0. Here doesn't really matter what we picked, just something between the two, so why not just pick t equals 3, and then something bigger than 8.6593. Let's just go with t equals 9. Okay, so again, we want to take these one at a time and put them into our A prime. So if I put 0 into A prime, the first term becomes 0, minus the second term becomes 0, and we're left with plus 1.867. So I get a positive number, which means that my function A is increasing. All right, if we put t equals 3 into A prime, what we get on our calculator is negative 0.1805. So that means we've got a negative here, which means that my function is decreasing in this entire range. And then lastly, we want to go ahead and put in 9 into our function and see what value we get for the derivative. So if I do that, I will get 0.1795. Important thing there is it is positive. So the function is increasing. Okay, so if we think about what's going on here, I'm just going to draw a little sketch on my number line. Increasing, and then decreasing, and then increasing again. Okay, so a graph that looks something like that. Okay, so important part here is at 2.613, I have a maximum because the graph is increasing then decreasing, and then at 8.6593 I have a minimum because the graph is decreasing and then it switches to increasing. Okay, so last thing we need to do for this part is to go ahead and get the A values or the Y values that go with these T's by taking 2.6134, plugging it back into the original A equation, and taking 8.6593, putting it into the original A equation. So if we go ahead and do that on our calculator, we will get A equaling 10.6042 and A equaling 7.5655. Okay, and we write these as ordered pairs, T first and then A second. Okay, and the last thing is to identify what kind of graph we have, what it looks like. So again, thinking about the number line here, my number line test is telling me that my graph increases till I hit 2.6134, and then it decreases until I get to 8.6593, and then it starts increasing again. So my graph has that general shape.